Welcome back. In this section, we'll run alpha-pipeline.py for multiple refit periods while taking advantage of parallelization. Parallelization is essential for faster computation. In this evaluation, you will be able to use a computer cluster, allowing you to leverage parallel computing. Simply put, this is done by distributing alpha-pipeline.py across multiple machines. Here are the steps needed to parallelize the pipeline. Step 1. Turn on the node balancer. Go to CWIQ bench and turn on the node balancer. Choose the appropriate instance type. Bench will automatically spawn instances when jobs are distributed. Step 2. Use the wrapper script. We have provided a script called qsubwrapper.py to simplify this process. To run it in the terminal, pass the following arguments. Start date, the start of the entire period for which predictions will be made. End date, the end of the entire period for which predictions will be made. Out dir, the path where all outputs will be saved. Script path, the full path to alpha-pipeline.py. Note: ensure the path is complete. Otherwise, the qsubwrapper will not run correctly. MEM, the amount of memory allocated for running a single refit period. Consider this when choosing the instance type for the node balancer. Refit frequency determines how often the model is trained. Options include monthly, 12 jobs per year, 1 for each month. Quarterly, 4 jobs per year. Eval path, the full path to the evaluation script. Script args, additional arguments for alpha-pipeline.py, passed as a string within quotations. Example: arguments like train lookback years and stay lookback can be included here. What happens next? Once these jobs are submitted, Bench will automatically open multiple instances and run the jobs in parallel. Participants will see the same outputs as alpha-pipeline.py in the output directory, but for multiple periods. Additionally, a results summary directory will be created. In the next video, we'll explore the contents of the results summary directory and how it can help participants evaluate their model performance.